We're going to work with functions as well. Functions will rule our lives for the rest of our computer science careers. And so they're going to help us with all this too. So let's make sure all this is the right size and stuff. But yeah, before we get to animation, I want to show you how to make stuff animated in Python in Turtleland. Let's talk about functions one more time since I'm going to use a bunch of them. All right, so functions, they're just a piece of code that you can run a bunch of times, and it can potentially do different things depending on the arguments that you pass along to, take the place of those parameters. So it's a rerunnable piece of code. So you say def, here's how you make a function, right? You say def, you give it a name, and you give maybe some parameters that are involved. Maybe it takes P1 and P2 and it'll work with those. Colon, tab over, and you give as much as you need to do your job. Do whatever func name was supposed to do. And then when you call it, down here, you just say its name, and you give the kinds of things you want it to work on. So maybe this time I want it to take 42 for P1 and 43 for P2. And they will just be placed into P1 and P2 and running, and it'll go and run the body, and hopefully it'll do whatever you want it, something cool. All right. Some functions don't want to just be called on lines by themselves. Some functions give back values, functions that return things. They give a value back to whoever called you. And so if you say return inside of your function, return, and you give some value, it will give back that value to the person who called you. We'll call them the caller. If you say return, that gives something back to the caller. That's key. And so you would want to, if you are going to return something in your function, you want to use it in a bigger place. Use it in a larger context, or at least save the value somewhere. So you say, you call your function sure with some arguments. Could be different arguments, doesn't matter. And then you want to use that result. If you're getting a result back, you better use it. So like add 1 to the result and like print it or save it away in a variable, something like that. So remember the difference between functions that just do stuff that are meant to be called on a line by themselves, and functions that return stuff where you better use that value because you're going to lose it if you don't. That's the idea. So that's the difference between functions that just like print something versus functions that like return something. So like the print function, you call it on a line by itself. You don't look at it gives you nothing back. But like if you call math.square root, right, that totally gives you a value back, and you better be using that. Otherwise, it made no sense to call it. All right? Any questions about functions? Are they coming back to us? All right, because I want to make functions that do turtle stuff. Let's make a function that draws a rectangle. That'll be fun. So we can use it a bunch of times and draw different rectangles. All right. So the first question is, how do you represent a rectangle? Like I want to make a function called draw rectangle. And then like, what do I give it? If I want to like draw this exact rectangle right here, what do I give? Like what should I be passing? What does it mean to represent this exact rectangle right here in this coordinate plane, right? It's like, how many arguments do I need to represent all that? Question mark, dot, dot, dot. Who knows? And so there are many valid answers for how to represent a rectangle in code. But one way, here's the way that I'll show you, you can represent a rectangle, the idea of a particular rectangle in space, by saying one corner of it. One way to do it is just like give the coordinates of every single corner of this rectangle. That's pretty heavy-handed. You can get by with just giving one coordinate, just like the upper left coordinate is 1, 5. And then if you give its height and width, do you see how that exactly describes only one rectangle? Like, if you tell somebody these 3 things about your rectangle, where its upper left coordinate is, its height and its width, everybody will be able to draw that same exact rectangle that you're thinking of. So that could be what we pass along. There's many other options, like give every coordinate, but they're all equivalent to this, and so here's a good one. Let's say that. Let's say that that's what we pass along. And so I want to teach you about a kind of type in Python that's very similar to lists. They're called tuples. And so instead of the, let me open up idle real quick, because we're going to use those to represent coordinates. And it looks just like coordinates, so it's perfect. So like in Python, this is a list, right? Square brackets 1, 2. You can give parentheses 1, 2, and that creates not a list. So what's the type of square brackets 1, 2? That was a list. What's the type of normal parentheses 1, 2? That's called a tuple. All right. That's the type of things, and you can have those be as long as you want them to be. So like this is 1, 2, 3, the tuple. And the reason they call it that is like this is a, I don't know, one thing is a single, double, triple, quadruple, quintuple, sextuple, septuple, all these things. But all the cool kids pronounce it tuple. So that's how I learned it. That's how I'll say it. But you can make it as long as you want, and it'll just hold on to all those values just like a list would. Like you can assign it into a variable, and its type is a tuple, and you can get at the individual pieces of it, just like you were, just like before. That's a tuple. So like x equals 1, 2, the tuple. Type of x. What is it? It's that thing. X of 0 is 1, x of 1 is 2. There is no x of 3. The one thing you can't do to a tuple is reassign things. It is read only. So like you can't make the x coordinate a 5. Tuple does not support assignment. So it's like once you say that, it's set. You cannot change it. That's kind of nice. So let's say that's how we represent a rectangle. And so we'll pass along, when we call it, we'll pass along a tuple. The first thing can be a coordinate, x and y coordinate, and then we can pass along width and height, and it will be 3 parameters total. Does that make sense? Any questions about that before we actually make that function? So we kind of answered this question. What parameters should it have? We need some way of like pinning down that rectangle. How do we describe a exact rectangle? I want this exact one right here. Everybody understands it. And so we have decided to take the upper left corner coordinate, and then the width and the height of the rectangle. That will represent a rectangle. Precisely. Draw a rectangle. And so it'll take 3 things when we define it. Let's call it UL for upper left coordinate. We take that as a parameter. Then W for width, H for height. And then essentially, how do you code this up? It's just like you just like tell the turtle to go to UL. This is like English, but imagine go to the upper left coordinate and like turn right and go forward by width, go down by height, all that fun stuff. So it's not going to be too hard once we have these things. I hope you see that. All right. So yeah. Here's how we want to like call this function, by the way. Draw a rectangle. I wanted to draw this one that I made up over here. So 1, 5 is the upper left. And you just pass that along as the first argument. 1, 5 as a tuple. And then 3 was the height and 4 was the width or something. Or 3 was the width, 4 was the height, something like that. So that's how you call this function. And it would just go off and it would draw stuff for you. And so we're passing along as one single argument coordinates as a tuple. So tuple is just another type. It's just essentially a list with the square brackets becoming parentheses. That's all. And you can mess with this function all day long. You can add an extra parameter for like, what color do you want to draw this rectangle? What color do you want to fill this rectangle? You can have a lot of fun with this, but this is just a simple example, I think. So does it make sense that once you have these things, you can draw a rectangle? You just like tell the turtle, go to that coordinate, that UL coordinate, and then like turn right, and then go forward by the width. That would draw this end, and then like turn right 90 degrees, go forward by the height, turn right 90 degrees, go forward by the width again, turn right 90 degrees, go forward by the height again. And that would draw that arbitrary rectangle, that generic rectangle that somebody told you to draw, where the values are in those variables, those parameters that got passed to you. Okay, so let's try that and go from there. So I'll make a new file. And I'll make a new folder for today too. What is this lecture? This is 24. what will I call it? Draw rectangle dot pi. And so if only I had this kind of function, I could call it like this. I could be like draw rectangle with the rectangle having its upper left coordinate at like 5100, and the width is 200, and the height is 300. Something like that. So let's make that function so that we can draw rectangles just with one line like that. Won't that be cool? So it's going to use the turtle library, of course, so import turtle. And then let's make the turtle look like a turtle because I like that. Turtle.shape, turtle as a string. That is not strictly necessary. And now let's make our function so that we can have it be called as many times as we want. So def draw rectangle, and we give the upper left coordinate as a parameter, the width, and the height. Those are our parameters right now. And then what do we do with those things? Well, we want to, like, what's the game plan? Let's make comments for it. It's, well, turtle, first go to UL, go there, move to UL, and then like face right, go forward by width, because that would draw that right side over there. I would draw that first, that top edge of the rectangle, then like turn right by 90, go forward by height, all that fun stuff. 90, go forward by height, and then I think you get the idea. Yeah. So once we have all these values, we can draw that rectangle. It's not too hard, right? And so here's how you do that. So move to UL. Don't draw any lines as you move there, though. So we are going to say turtle.goto. You can give the x and the y coordinates. You can just pass along UL, honestly. But technically, right, the documentation for Python turtle, that goto function takes two things. It takes the x and the y coordinates, so we can extract those. Goto. You can give it both. So you can say this. Because what is UL? UL is this whole thing. UL is this whole tuple. And so UL of 0 is this, is the 1. And UL of 2 is the 5. You can use indices to get the x and the y. So go to UL of 0, comma, that's the x coordinate, UL of 1. So that's how you can extract the x part for the first argument of goto, and the y part for the second argument of goto. I hope that makes sense. So that's that one. And then we don't want to make any marks as we go here. This is just like set up, get set up. So we should say turtle dot pick your tail up as you're moving there. And then we'll put you back down. And now we're ready to start drawing. All right, so face right, that's turtle dot set heading, and 0 is apparently facing east. That's that. And then go forward by width, turtle dot forward. What is width? It's whatever the user passed. It was placed into the W variable, the W parameter. Yeah? And then turn right by 90, turtle dot right 90, go forward by height. It's just turtle dot forward H this time, whatever that was, whatever the user gave. And so that's drawn half of the rectangle. We've gone to here so far. And then it's just right 90, go width, right 90, go height. Yeah? So right 90, go forward by width. And then right 90, go forward by height. And so, oops, gotta keep that indented, of course. And so that's the definition. Now I can use that function wherever I want. For example, down here. And so, without any further ado, are there any questions about how this code generates this rectangle? I'm asking it to draw this rectangle right here that starts with its upper left at 5100, so like 5100. And it's width 200 and height 300, so it's higher than it is wide. Any questions about how that's working? It's getting those values and it's drawing a rectangle. That's pretty cool. And the whole point of making functions is that you can use it as many times as you want. You've done the hard work of saying how to draw some arbitrary rectangle, and now you get to enjoy the fruit of your labor by calling that function as many times as you want. All right, let's draw another rectangle. negative 50. The upper left can be negative 50, negative 200, and it can be, I don't know, a small one. It can be 50 by 30. Why not? So this will draw two rectangles now. Just going to go there, go to the next one, start drawing it. Does that make sense? Isn't that beautiful? Draw 100 rectangles now that you have these functions to do it. That's pretty cool. Let's draw one more. Let's draw one right in the middle. So its upper left can be 0, 0, and it can be a square. So let's make it 75 by 75. Medium-sized, not a normal rectangle, but a square, because the width and the height will be the same. Cool. All right, so once we define this, we can start using it as many times as we would like. Does that make enough sense to us? Any questions about that before I make this fancier, before I add to this function? So yeah, let's do that idea at the bottom there. Let's add a color parameter. Let's ask the user to also pass along what color they would like this this rectangle to be like outlined by. You can also add a fill color parameter too, if you would like, and you can do like the begin and the end fill. But let's add a color parameter here and have the user also pass along what color they want this rectangle to be. And once they do, right, if we say like this one, let's make it black. And they pass along the string, right? This one make it red. This one make it blue. We use that. How do we set the color of the rectangle that we're about to draw? That's the turtle's pen color. Remember that? So just like before you start drawing anything, set the turtle's pen color to whatever the color was, the color that was passed to you. It's set into this color parameter. So we'll take it, just like a variable. And then you can pass along a value in your fourth parameter for that. And now it'll set the pen color right before it starts drawing anything, and it makes it that color that you passed along. So there's a black one, there's a red one, and then there's a blue one. That was very simple. Simple addition, new parameter, got to use it everywhere, got to add it to all of our calls, but now we get some cooler looking output. So that's the beauty of functions, I would say. How are we doing? Good enough? Make enough sense? Alright, please do yell at me if you have any questions about this, but this is the kind of example stuff that I want to give today. Let's use functions plus turtle to make cool looking things. So let's move on. Let's make a function that draws a letter, because I think you've learned as you were drawing your initials in your graduation year, like you did your LN20, that's what I would have done, right? Maybe you drew your 2 like this. You had to pick a little bounding box for all of your letters, right? That's how I taught you to draw them all. Like there's a little rectangle secretly surrounding all of your letters, more or less. And wouldn't it be nice if you could make a really fat letter, a really tall letter, and have it be whatever you wanted? So what if you passed along, like once you choose a width and a height for your letter, wouldn't it be nice to have like a function that would draw a letter with that width and height? And that's where I'm going with this. It's like, ooh, draw an L, just like that, with that exact width and that exact height. Or if you, then you pass along the upper left coordinate, of course. Or if you give like this rectangle with this width and this height, if you pass that along to your L drawing function, it could go off and it can draw this kind of L. That's kind of nice. Be cool to have. So let's make a function that works like this, where you can pass along a bounding rectangle, or like the upper left coordinate, the width and the height of a bounding rectangle, and it will draw a letter within that rectangle. That's the goal. So let's do that with, I did L here as an example. Let's do my last initial. Let's do an N. All right. So let's make a resizable N character, and you can do it for your initial too if you'd like. Do a different one. We'll erase. So the key idea here is we can bound every letter. We can like put a rectangle in, put a rectangle as like the outer edge of that thing, of that character. And so like if I want to draw an N that looks like this, I just got to pass along an upper left, a width, and a height, and it will fill in this idea of, all right, I'll make an N just like this. Or if you pass along this upper left and width and height, it'll make a very skinny n. I'll do it like this. So that really is all you need, though, because you can calculate coordinates of everybody based on the upper left, the width, and the height. That's all you need to draw your n. So yeah, so given that rectangle, if the user passes you a rectangle, that's where I want you to draw the letter inside of. You can draw any character inside of that space. So we're going to make a draw n function. Def draw n. You can make one for your own initial if you would like. But all you need to pass along is where you want it. What is the rectangle that bounds that that letter? So give it upper left coordinate of the rectangle, the width, and the height. And then the body just uses these to draw that character. Does that make sense? So let's plan this out, because like it could be anything. The user is passing along a rectangle where they want that n to be drawn, or whatever letter it was. So they're kind of doing this. So once we plan this out, it'll be very easy, right? This is the upper left coordinate that's being passed to us. It's made up of an x and a y. Yeah? And then we're also given a width and a height. And we would like to do this. We'd like to essentially like figure out this coordinate so that we can start there, then go to here, then go to the opposite diagonal, and then go to here. If you just did a bunch of go-tos, do you see how that would draw an n within that rectangle? That's kind of what we want. We need to calculate this coordinate. We already have this coordinate. Then we tell it to go to this coordinate, whatever this is, down here, and then go straight up to whatever this coordinate is. So just a bunch of go-tos would draw this n. You see that? If you do it in the right order. So we have the x, y. Let's figure out what the other ones would be. If this is x comma y, it's the same height, right? Or let's do it in order. Like, what's this one down here? That's where we start, yeah? This is the same x coordinate, yeah? Same x coordinate, but we went down. We went down in the y direction by how much? We were up here at y, and we're down here at y minus h. So I'm calculating that. So this coordinate down here, the bottom left of this rectangle, would have been y minus h. And I can calculate that. That's part of what I'm being given to this function. So that's where I start, then go to xy, go to ul, and then go down to here. What's this coordinate? This is going to be, well, it is a bigger x coordinate. It was like, this is the x coordinate. This is x plus w. You see that? We went to the right. X plus to the right in the positive direction by w. That brought us to this line. That's the new x coordinate. And then the new y coordinate is, well, this was y. This is y minus a little bit. It's minus h. X plus w, y minus h. And so that means this coordinate right here is x plus w, and then it's the same y as the first, as the upper left. Are there any questions about how I calculated those corners, all the coordinates of them, using the width and the height? It's like, all right, this one must be, the x coordinate of this one must be whatever this original one was, plus the width, because we moved over by the width. It's the same y, same height. If you move down, you're moving down by the height, so it's minus h in the negative y direction. So you gotta subtract, right? But now that I have these coordinates, I can just like go to here, then go to here, then go to here, then go to here, and it will draw that in. Yeah? So I think that's what I want to show you if we are ready. We did all the work on paper. Now it's very easy to program. We can make many different kinds of ends, and I'll copy most of this because it really is a lot of mostly rectangle drawing. So all this I'll take and copy into a new file for our end drawing. Draw n.py. I'll paste it. So instead of draw rectangle, we're going to call this draw n, and we're going to get rid of the color. Let's just make every rectangle or every letter black. So I'll get rid of these as well. Everything else, like let's make an n within this rectangle. Let's make an n within this one, a square kind of n. So what do we need to do? We need to draw that in somehow. We need to first start at upper left, right? That's where the upper left coordinate of this is. And the upper left coordinate is made up of x and y. How do I get them out? Well, again, it's the x coordinate is the 0th thing in that tuple, because UL looks like this, right? It looks like 50, 100. If you go to the 0th index, that gets you the x coordinate. If you go to the 1 index, that gets you the y coordinate. So y equals UL1. I'll extract that. And now I'll draw, using that as my guide, draw a width w by h n character. Yeah. And so what do we want to do? We want to start at x comma y minus h. That was our starting point. Let's see if I can get that on the same screen for you. There. Kind of. So I want to start at x comma y minus h. So I'll go there first. So turtle.go to x comma y minus h. I've got all those variables now. I've made the x. I've extracted that out of UL. Same with y. And then here's h. It was passed to me. So go there. But also don't make any marks as you go there. So turtle up first. And then turtle down. Now we're ready. And then just like go to all the other places. Go to x comma y. I'll draw the first part. Then go to x comma y. So that will draw like we started at the bottom left. Then we went up to the top left. That will draw this part of the end. And then we want to draw this one. So we were here. Let's go to here. Go to x plus w y minus h. I'm sorry, I can't see that. X plus w y minus h. And then one last time, that will give us most of this. So go from here to here. And so now the turtle's sitting here. Just go to here. Go to x plus w comma y. And that will take us to our last place. Yeah. So x plus w comma y. And that should give me that arbitrary sized n. Whatever size that I passed along. And sorry, it's not draw rectangle anymore. These are all calls to our new draw n function. And that should do it. That diagram, it really wasn't that hard. So now it's drawing a bunch of weird sized ends. Cool. Any questions about how that worked? Does that make enough sense? How we extracted all the pieces, we figured out what to do, and then we can draw as many as we want with all these calls. And by the way, all of these functions that we've made today, draw rectangle, draw n, notice how they don't return anything. So it should be very clear that they can only be called on lines by themselves. They're meant to just go off and do something for us. Can't like add 42 to the answer that it gives back because it gives back nothing at all. Right? So it just goes in and does something. It messes with the screen. That's important to understand. Yeah, if we're good with that, you try. I'll put this code on the screen for my draw n, and then here, you try to make some code that does like a resizable L, do my other initial, or do your own initial. Something that you've already done. Make it personal. So here's my code. And try to modify it to make a resizable character of your choosing. Here's the code and the directions there. I'll give you a few minutes to try that. So yell at me if you have any questions about that. All right, that was my timer. So it might be a little difficult, like if you have like an initial that's a little weird. That's not like it has some curves to it, or it's not like along corners. Like a Z would be easy. That's like an N. But like an A, how would you calculate the middle if you want to do it? I don't know, something like this. That might get a little weird. You have to like calculate the midpoint between this corner of the rectangle and this corner of the rectangle, and that's where you could draw that. So it could get fun and interesting, and I encourage you to keep playing around if you didn't get it in that amount of time. But yeah, that's where I want to let you stop there, and you can come back to it later. But are there any questions before we move on to one last thing? Take a little bit of time. So try making a resizable one of your initials. I think that would be fun. You can draw a million of them with a loop, because now you know that. Of random sizes and random locations. So let's make for our last example, this is going to eventually lead to a full-blown game, but let's make an example of a ball dropping. Let's make an animation in the turtle land, all right? And so I'll have to teach you about animation, but the goal for today at least is to have a little ball, a little circle that, like, let's not worry about gravity for now, but let's have it just start slowly move this way towards the edge of the screen, and then bounce off the bottom and then start slowly moving towards the top and then bounce off the top. And so just keep on moving at constant speed, up and down, just keep bouncing off the edges. So that's the goal for the rest of today, right? So let's get there. We have to talk about animation because we haven't made any animated things in the turtle land yet, in the turtle library. I mean, technically it's when you run your programs that the turtle is drawing stuff slowly but surely. Like, that doesn't count as animation though. So let's figure out what animation it really is, because we have to go a little bit more low level than we did with Scratch. Scratch made it very easy. We have to like do it ourselves this time in Python. So what is animation? It's just moving pictures, right? Hopefully we've seen this, like the old idea of like a film being shown to you. It's just you got a film reel, and you put a bunch of you're just turning it very fast in front of a light, and you have all these different frames, right? A bunch of different tiny pictures being shown to you for fractions of a second. So everybody knows that. Hopefully we've seen that before, we understand it. But that's all animation is. You just got a bunch of, like a reel of film shown to you very rapidly, a bunch of different images shown to you quickly. You perceive that as actually moving. So every different image that you see very quickly is called a frame. So maybe like you made a little flip book when you were in elementary school, like I did. Like, what do we want to do? We want to have like one frame where the ball is up here, and then the next frame where the ball's moved a little bit. And then in the next frame, the ball should move a little bit more. Yeah, that's kind of what we're going to do in code. And I hope we all understand that leads to animation. If you just show somebody that really quickly, that'll look like the ball's moving. So those are your frames. We're going to make a bunch of those. All right. And we don't really get a choice over this in Python. You can calculate it if you really wanted to, but it's not really important to us. But when you show the images quicker, when the images change faster, that means you have a higher what's called frame rate. Maybe you've heard that word before. So like in the movies, the movie frame rate in standard one is 24 frames per second, 24 FPS. So you're shown 24 images per second very quickly. So each image exists on the screen for 1/24th of a second, and you perceive that as like real and animated and moving. So that's the goal. We're going to do something like this. We're going to like set up a bunch of images that we're going to draw with the turtle, and we're going to show them to the user for a split second, each one of them, and then we'll go to the next one, and that will appear as animation. All right, so that's the goal, and let's make it happen. Let's see, where do I want to be? I want to be here. So this is going to get interesting. All right, so let's make this ball dropped, and it keeps bouncing. All right, so all right, I'm eventually going to make a draw frame function, but let's start this off. Let's make a window that the ball will bounce around. All right, let's not just use the original window. Let's make a bounding square and have the ball bounce off the top and the bottom walls of that square. All right, so we're going to do this. We're going to be like, here's our square. We're going to draw that first. And then that's where the ball that we're about to put inside is going to like live, and it's going to move up and down. So that's the goal. So like, let's say that this is a 400 by 400 square centered in the middle of our turtle land. So if that means this is 0, 0, and that means this must be, the upper left coordinate of it must be, if we want to reuse our draw rectangle function, this better be negative 200, positive 200. Yeah. So let's draw that first, and then we're going to place a ball inside, and then we can easily see like where the walls are. That's the start. So I'm going to steal our draw rectangle function and copy and paste that into a new file, which I will call bounce.py. I'll change some stuff around. Let's start there though. So what I want to do is keep the draw rectangle function. It'll just be one color. We don't need to worry about colors. And then what I'd like to do is have one call to that function that draws our bounding rectangle for this screen. It's going to look this exact rectangle, right? And that's where we're going to make our animation live. So that's the very first thing that I want to do. I want to draw the bounding square, that is the walls that the ball that we're about to make will bounce off of. All right, so that is going to be centered at, the upper left coordinate is going to be negative 200, positive 200. And then the width will be 400. The height will be 400. So it's a square. And so if I run that, I'll just draw one rectangle. But this is like the little window where we'll make a little ball, and it will move and bounce off the edges of this wall up and down. Okay? That's where we're going with that. So that's the start of it. Let's see. And then we want to have a ball that bounces off of these walls. So it's like, here is the ball. And we're going to start it up at the top and moving downward, and it will eventually hit the bottom and come right back up and keep on bouncing up and down, up and down. So like if this were the ball, this is what it's going to do. Like, boop, bounce, go back up, bounce, 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 just all day long. It'll do that. That's the goal. All right. So, yeah, let's get the ball in the starting position. Let's do that first. All right. So we're going to cheat, actually. It just so happens that one of the options for the turtle, like you can make him look like a turtle, but you can also, what am I doing here? Shape. You can also set the shape of the turtle to a circle. So we are going to use the turtle as the ball. Okay? That's what we're going to do. We're going to change his shape to a circle, and then we're going to put him in the right spot. All right? So let me show that to you. So if I change the shape of the turtle right now, he can become the ball. Turtle.shape circle. And this can be, just give it as a string, single or double quotes. It doesn't care. There's that. And watch. Boop. So now he's a circle in the upper left coordinate, which is not where we want him to be. And he's also a little small, so let's make him larger as well. We can change the size of the turtle by, I think it's turtle.turtle size, and you can stretch him in the width axis, the x-axis, and the y-axis. Let's stretch him equally in both. Let's make him twice the size. So we can say turtle.turtle size 2 times in both axes. And so now there's a ball, and you can change the color of this ball by changing the fill color of the turtle, if you remember that. So let's set the fill color of the turtle to, like, I don't know, pink or something. That's what I did last time. And so the turtle will function as the ball. And we just got to get it in the right spot. Start it off over here. Okay? That's our goal. So let's do that. Let's move him to the middle somewhere. So we got to make him go to somewhere. Okay? Does that make sense? So let's see here. What we'd like to do is tell the turtle to go to here, right? Go to this spot, which is the x coordinate is 0, but the y coordinate is something. The x, is it like, maybe it's 200? Let's try that. Let's be like, turtle. Don't make any marks either, turtle. Turtle.up, and then turtle.go to 0, 200. Is that going to work? Not quite. That is outside the wall. Do you see that? Because the turtle's coordinates is always relative to his center. All right. So if we want him to be at the tippy top, we got to move him down by half his size. See that? Half his height. And so we have to figure out like how tall is the turtle right now? Is this little circle thing? And I've done this ahead of time. He is apparently, like, we don't want him to end up here. We want him to like move him down by half of his height. He's apparently 40 units wide and tall right now. So let's save that in a variable somewhere. So the turtle's width right now, turtle, which is also his height, turtle width equals 40. And we want him to not go here, go to 0, 200, but like 0, 200 minus half of his width. Turtle width over 2. Something like that. That'll work better. So that'll start him out in the right spot. Are there any questions about any of that? That's going to be the goal. So, yeah. We're going to move the turtle now, and so we have to keep track of like where he is, what are his coordinates now, and what do we want his coordinates to be in the next frame, right? So let's make variables for all this stuff. That's going to be the name of the game right now. Let's make variables for where the turtle right now is, and we'll just always update the turtle to match those variables. So like turtle, where do we want him to start? Turtle X. We'll make a variable for that. Start him off at 0. What should the turtle's starting y coordinate be? always let these variables eventually command the turtle to move there. His y coordinate should be 200 minus his width over 2, whatever that was. And then we're going to move him a little bit every frame. We're going to change his, not x coordinate, because that moves him left to right. We're going to change his y coordinate. That's all that needs to change, by a little bit. Like move him down a little bit. Change the y coordinate to be a little bit more, a little bit smaller, a little bit smaller, a little bit smaller, until you hit the bottom. Okay, that's where we're going. So ever so slightly, every frame, we're going to change the turtle's current y coordinate to be a little bit less at the start at least. And I'm going to make a function that does that, all right? And so we'll also add bouncing after we've got that going. But we're going to repeatedly move the turtle, all right? So change his y coordinate a little bit every time by some offset, okay? Turtle, I'll make a new variable for that, turtle offset, let's say. It should be negative to start, and this is going to give us direction. If we add that into our y variable, see how that'll make it smaller by 5 each frame? So he'll move downwards if we always tell the turtle to like keep in line, keep in sync with x and y, these variables. That gives us direction if we repeatedly do that. So this is like pseudocode. Repeatedly, this is not really Python, but we'll translate it to Python. So repeatedly, what do we need to do? We need to change the turtle y every frame. Turtle y equals whatever it was plus that offset, turtle offset. So that like if it was 200, now it's 195. If it was 195, now it's 190. He's moving down by 5 units each time because that was our offset. And so each frame, the ball will move a little bit each frame. And then we want to redraw the turtle because these variables don't affect the turtle, right? If you want the turtle to move, you say turtle.goto. So we eventually want to use these variables to command the turtle. Redraw the turtle. And if you do this a bunch of times fast, that will create some kind of frame rate, which we can't really measure, but the turtle will go to a new spot and it will look like he's animated. Are there any questions about that game plan? These variables, do they make enough sense? This offset is corresponding to the direction that we want the turtle to move in. We want to change his y by this amount, direction. And I think you can imagine that once he hits the bottom, we want the offset to be positive so that the ball starts moving upwards to hit the top wall again. That's going to be our goal. So let's do that, and then we'll add to it. I got some other stuff that I want to do, but that's going to be the start of it all. So let's set all this up in code and go from there. So we want a bunch of variables to like keep track of where the turtle currently is. So let's make all those. So let's do turtle x, that starts off at 0. And then turtle y, that is 200 minus turtle width over 2. And then the offset, turtle offset, that can be -5 to start because we want it to move down. Offset the y by -5 each time right now because that'll move it down. And then, so we're going to keep using these. So we'll use these variables to keep track of where the ball is, where the ball should be, and where it should move. Where it is right now, and we'll change it if we want it to move somewhere, all right? And so now, the name of the game is just always have these variables affect where the turtle is. So like repeatedly, turtle go to whatever the turtle x we're saying it should be, and whatever the turtle y should be, and that's the initial value, turtle y. And I can just always set it up because we don't need to make any more marks. So put the turtle in the correct starting location. All right, so that's everything we did before, just extracted into variables. So that's got the ball at the start, and now we want to repeatedly move it downwards, bounce off the wall, move it up. Okay, any questions about this so far? So we're going to use these variables to keep track of where the turtle is and where he should be, and then we're going to always just tell him to go to those new values because we're going to keep changing turtle x and turtle y. Tell them to move somewhere. So repeatedly, what does this mean? So repeatedly do stuff. Change these things, redraw the turtle, and let's put that all into a function. So like while true, repeatedly, until the end of time, repeatedly draw a new frame. And so we'll just make a draw frame function that does everything else. All right? That's kind of clean looking here. Just repeatedly draw a new frame based on whatever the turtle is right now. So all we got to do is implement whatever we should do for draw frame. And that's, of course, going to be the hardest part. So what do we want to do each frame? What do we want to have happen? We would like to mess with the turtle's offset and redraw the turtle there at its new XY coordinate. Right? So change every time we're in the draw frame. We're going to draw a new frame right now. We want to change the turtle's Y coordinate by the offset. So turtle Y, if I can spell turtle, equals whatever it was, plus turtle offset. If it's negative, it'll move it down. If it's positive, it'll move it up. And now we want to redraw the turtle. So turtle.goto, wherever turtle X and turtle Y are. Because Y has changed. X is staying the same, but Y is changing. And so now the turtle will go to some new spot. If we just do this really fast, a bunch of draw frames per second, it will look animated. Well, it will be so cool. So, one thing that you do have to do here is because you're changing a global variable inside of a function, you got to tell Python about that. It's like, global turtle Y. I want to be able to mess with it, please. All right. So this is the new code. Draw frame repeatedly forever. Draw a new frame and just keep on running this, which changes the Y and redraws the turtle at a new Y location. So it got smaller based on that offset. Watch. Whee! And then it falls off the edge because we don't bounce yet. Cool. So let's, the offset is how fast we move per frame, how much Y offsets we're doing per frame. So if you make this a smaller, closer to 0 offset, I guess technically bigger if it's negative, that will move less per frame. So it'll look like it's moving slower. Whee! That's kind of nice. -2 is a good offset. Are there any questions about how we got that from this code? Just like repeatedly tell the turtle to go somewhere new, give him a new Y coordinate that's getting smaller because turtle offset is negative. Just keep on in a loop forever, changing that coordinate of the Y and telling the turtle to go to that new coordinate. X is staying the same, Y is changing, getting smaller. So we're moving straight down. Okay? That's a lot. This is going to be fun to study for sure, though. But what we would like to do is, let's see. We want to make him bounce now, right? So let's make the turtle bounce. How do we do that? How do we check if we hit the bottom or the top? All right. So it's going to be an if statement, a couple if statements actually. So if it got so small, if the turtle's XY coordinates got so small that they're down here, or maybe they even passed it, we're trying to move them outside of this, we would like to bounce up now, please. All right, so here's the idea. I'll write it in code. So if we hit it, we have to add some changes to here, because maybe we don't want to go downwards if it's outside of this, if turtle Y is now outside of the bounds of this rectangle. So if we hit a wall, we need to bounce off. And how do we do that? How do we figure that out? How do we figure out if we hit a wall? All right. So the idea is we know we're outside the wall, right? If our Y coordinate, we know we're down past the edge of the bottom wall. If our Y coordinate is smaller than, this is -200. Does that make sense? If our Y coordinate is trying to get that small, then we're definitely outside. And we just grazed the wall if our Y coordinate is equal to -200 plus half our width, half our height. Does that make sense? That's when we just graze the bottom wall, and that's when we immediately want to bounce off. If we're there or any lower than that, we need to bounce. Okay? That's if we hit the bottom wall. So here's how you write that in code. We just graze the bottom wall if turtle's Y is equal to -200 and then up a little bit plus turtle width over 2. We just graze the wall if that's true. And if we ever try to go even lower than that, so if we're less than or equal to, we're definitely off the bottom wall. All right. So if this is true, then we either hit the bottom wall if it's equal, exactly, based on our offset, that may or may not ever happen, or we're trying to go outside of that wall. We haven't actually moved the turtle outside of the wall because that's the go-to down here. Or we're trying to exit the bounding box. Or we're trying to go below it. So the first thing that we should definitely do right now is don't draw the turtle there because he's outside. He might be outside or he might just be hitting the wall. So if he is outside, if it's really less than, bring him back in to be exactly grazing the wall. Set his Y to be exactly this. So move the turtle back inside, definitely, if he was ever outside. So we can do that with one line here. Move the turtle back inside. Just set his Y. If it was ever smaller than this, set it to exactly equal to grazing that bottom wall. Just bouncing right there. And then, for the rest of time, right, now we're at the bottom, we want to move up. We don't want to go down anymore. So we want to change our offset. Don't make it -5 anymore, make it +5 so that I go up now. The next frame I increase my Y. The next frame I increase my Y. Does that make sense? If I do that, I will get movement upwards. That's what I would like to do now. So, change the turtle offset so that we move upwards now. And if I want to change a global variable, again, I have to give its name and say global. So, turtle offset. It was -2. I want to make it +2. I want to change its sign. So an easy way to do that is say turtle offset equals whatever it was times -1. Okay? So that's how that works. So if we ever, let me try and explain what this if statement is doing. If the turtle's Y is ever exactly equal to hitting the bottom wall, that's -200 plus half of our height. So right there, that's our center. If we're ever there, or smaller than there, or lower, trying to go outside the wall, rein the turtle back in to be just grazing the wall, and then change the offset to be positive so that we're moving up for the next round, for the next few frames. Okay? That's what we're trying to do here with that if statement. And so, as that's part of it, we'll never get the turtle outside the wall because right before the go-to, if that ever tries to happen, we'll be moving the turtle upwards. So here's bouncing off the bottom wall. Boop, and beautiful. And then we're going to go upwards forever because we haven't dealing with the top wall. We haven't fixed that yet. But are there any questions about why this code will bounce the turtle off the bottom and it will never look like the turtle went outside? Some cool math going on here. It's just so satisfying to watch it work, though. We good? All right, so we need another one of these for the top wall. All right, so how do we know if the turtle hit the top wall? We know that the turtle hit the top wall if his Y, again, it's with the Y coordinate, if the Y is ever just exactly equal to, this is +200 now, right? +200 minus his height, so that's that coordinate. If it's ever equal to that, 200 minus his height over 2, or any bigger than that, because that means you're trying to go outside the walls. So if that's ever true, rein him back in, make him exactly graze that wall, and then again, he was moving up, make him move down now. Make the offset negative again. Does that make sense? That's what we want to do. That's exactly what we want to do here. And so that turns into another if statement that looks very, very similar. So if the Y for the turtle, this is the top wall now, if the Y is ever greater than or equal to +200 minus his width over 2, because that would put him right here. This is equal to +200, and this would be equal to +200 minus half of his width. That's right on the wall, or any bigger than that. Then we either just hit the top wall or trying to go above it. So let's move the turtle back inside. So his Y better become exactly this now. Make him graze the wall if he wasn't already. And then change the offset so that we move downwards now. We came in, we hit this top wall. Because we were moving upwards, we need to change our offset to be negative rather than positive so that we move downwards in the next frame. And then again, we did all this before we ever redrew the turtle, so he never looked like he went outside, because the go-to is actually changing the turtle's position, really. We were just messing with variables up until here, okay? That's the magic of it all. So draw frames got a lot to do now, but if we just repeatedly call that function, every round of our loop as fast as we can, we will get animation and we'll bounce off walls. Whee! So there it goes. Are there any questions about how this code, how this draw frame function corresponds to bouncing off walls and actually producing animation? I think it's so cool. And so if this ever gets so small, we go outside, we hit this first if state, we move them back up inside of the walls, and then shoot him off upwards, change his offset, because he's coming down, make the offset positive, so that it looks like he's moving up. Change his y coordinate. And then the opposite for this one, if ever too high, rein him back in, and make him go downwards. The offset was going positive, moving him up. We want the y to change in the negative direction now, so that he's moving down again. All right? Does that make enough sense? Well, this is definitely a complicated example, but it's so cool looking. I hope you agree. Yeah, so if we are happy enough with that, definitely this is a program to study, I would say. It's a great example of a lot of stuff. Let's add one more cool thing. Let's change his, because we weren't touching the x coordinate ever. Let's just have fun with that. Let's make, every time we start the program, let's have the x coordinate of the ball go to some random place. Like maybe the ball starts its life over here. Maybe the ball starts its life over here. Maybe randomly it does start in the middle. But let's make it different every time. But still at the top, just some weird x coordinate that's random. That will be the last piece of this puzzle. And then I think that's all that I want to say. So the turtle x, let's not put it straight in the middle. Let's not put it 0. Let's make it random. So I'll include the random library. And change it to be a little cooler looking. So, I don't know, turtles x, let's start it to be a random integer, random.randint, between, I don't know, negative 100 and positive 100. So now when I start the life of this program, the life of the ball will be some random x coordinate too. So that was pretty randomly in the middle. That's pretty funny. Let's try it again. And so here it's a little bit more towards the left. I don't know. But it'll always stay that value because we're never changing turtle x ever again. But at least now it's slightly different every time. And so, all right, one last time. Let's explain all this while it's running and being cool looking. So, what have we done? At the very start of the program, we drew this rectangle. We drew this little square. That is our scene. And that was using our draw rectangle function. We drew this little bounding square, 400 by 400, perfectly centered with this call. Then we turned the circle into the ball that's going to bounce, which is pretty nice. Made him a circle, made him pink, stretched him out. You can make the turtle even bigger, but that would change his width, and you have to mess with that too. And then we promised ourselves to use these variables to keep track of where we would like the ball to be and how we want it to move. The offset is how we want it to move as well. And so as long as we just keep on updating these and having the turtle reflect the changes to them, then we are going to produce animation, right? So the turtle started out in the right spot, and then forever until the end of time, just draw a new frame based on where the turtle was, move him a little bit in the direction you want to move him, and that will produce animation. So there is no place that we're actually defining our frame rate, like we're doing exactly 24 frames per second. It's just however fast your computer is, however fast it can get through this loop. It takes some time to redraw the turtle in new places. And so honestly, if you use the -2 as the offset, it might look faster on your giant machines in front of you right now because it can handle that better than my tiny laptop. That's kind of interesting to think about. But the bulk of the work is done in this draw frame function, which takes the existing turtle x, turtle y, turtle offset and messes with them. It's like, all right, how do we produce movement? The next frame better be a little bit offset from the previous one. So the new turtle y, where we want him to be in this new frame that we're about to draw in this function call, a little bit offset from where he was. So let's do there. And then we'll bounce off the wall if we ever are too high or this is too low or too high. And then finally, we've taken so much care to change the values. We've used turtle x and turtle y to mean where we want the turtle to be. Actually draw the turtle there with the go-to call. Okay? So I think that's all that I wanted to say about that. Any last questions? I'll give you this code, of course. It'll be fun for you to look at it and play around, I think. Maybe try making the ball bigger. Try changing the color of it. Make it yours. But I think that is exciting. In the last few minutes of today, I want to give you your next and final extra credit assignment if you would like to do it. This one is also worth up to 5% extra credit. So it'll be due in a month exactly. So due December 1st at midnight if you'd like to do it. So you got exactly a month to do it. And for this one, I would like you to make a review video because I will be testing you on writing Python code on the final. Like I couldn't test you on Scratch in the midterm. It would be very hard for you like to give screenshots or something. It's very easy for me to ask you Python questions on the final, right? It's just you're pasting text into Canvas. So prepare for that by, this is one way of me forcing you to study. So if you would like some extra credit and also to help your peers and maybe if it's a good video, my future students, review Python, you can make a little review video where you go through kind of the stuff that I've been talking about, you make some new examples, and you have fun with it. So for your submission, just submit like a public link like on YouTube, or you can also upload videos to Canvas itself, but just like click reply here and upload your review video. So make a Python review, all right? This is me forcing you to study for the final. So here are your requirements. If you'd like to do this, you must have a bunch of Python examples of concepts that we've been talking about in class, right? So give some turtle examples, things that I haven't done. Come up with some fun scenarios, some maybe fun animation now that you know how to do that. So be creative. You can't just copy the code that I wrote in lecture. That's not extra credit worthy, right? So, but yeah, review something, come up with some cool scenarios, some cool programs to write, and just like pretend to be a teacher maybe. Demonstrate what's going on, and I'll give you some extra credit for doing that. And then your peers will love you forever because they'll watch that video and they'll do good on the final. So if you want half the extra credit, do at least a 15-minute video with 15 minutes worth of review and you typing code and explaining it. And if you want the full 5%, make a 30-minute video. Okay? You don't have to like edit anything, just post the video. That's fine. But do ask me if you're not sure if that your idea is extra credit worthy. As long as you're making something new, that's the bold part, right? As long as you're making something new, I'm happy. So like make new code, new slides, new diagrams, stuff like that. But just make sure that it's substantial, it's extra credit worthy. I'd be happy to look it over if you'd like before you do it. But that's pretty much it. Make a Python review video. That'll help you and your fellow peers study for the final exam because that's slowly but surely coming up, and we'll talk about that as we get closer to the end of the semester. Okay? So yeah, any questions about this extra credit opportunity? I'm not giving you like a list of topics or anything yet, but this is exact. I'm calling it a review. So yes, it is a review. And I want you to go over different Python topics that we've been talking about. So like we talked about the turtle library, we talked about randomness. Maybe you can combine the two and make something cool that I have not made in class. That's kind of the idea. What was your question? That would be too easy, you copying and pasting my code, yeah. I think that would be fair, yeah. Like I've shown you how to draw a square. I'm not saying that you can never draw a square in your review video, but you got to do something a bit more substantial with my existing code. Okay? Yeah. Any other questions? Yeah, just let me know. Ask me if you have any worries about it. I'd be happy to look over your idea. But I think that's all that I wanted to say. So, yeah. That's all I got, and I'll see you next time.